how do I know when to use a product rule versus a chain rule? So if I go and I want to write this into like f of x's and g of x's and stuff, to me this looks like just a composition. Right? There's no way I can write this as the product of two things unless I wanted to think about it as like I could do that and then do like 3 product rules to differentiate that if I wanted to, but like, no thank you. Right? Because I have, again, I'd have, think about this as like f, g, h, and k, 4 functions multiplied together. You could think about it as a product rule that way. I would not recommend doing that as that seems cumbersome, but the derivative, like applying the product rule, would not be too difficult, remember, because we've talked about this shortcut. We proved this one in class. Right? So each of these would come out to be 2x times x squared minus 3 to the third. And then you'd add those up, so you'd get like 8. Well, we'd have really, let's write 4 2x times. To have like 4 of those, right? Or really just 8x of those, which is, I think, the same thing that Talika wrote here, right? But like, you know, to answer your question, Elaine, that's basically, is there a composition going on? Or is there a multiplication of 2 functions going on? So if I look at this, I see no obvious multiplication the way it's currently written. Now I could do what I did there and make it multiplication, but like, why? Right? When it seems like very tailor-made to be a chain rule. If we look at Emma's down here, again, to me, this looks like a very obvious chain rule situation. Yeah, with a quotient rule inside. So if I wanted to do the derivative of this, and I get my chain rule, when it comes time to doing the derivative of that inside, there I would need to use a quotient rule to do that derivative. Bless you. Does that? Yes. And this is the hardest part really of this test, will be identifying which derivative rules I need to use and in what combination do I need to use them. Right? It might be easy to recognize that 3 is a quotient rule and a chain rule, but we have to make sure that we're doing the chain with the quotient nested inside of that, right? Not the quotient first and the chain after or something like this, right? So it's just about like getting comfortable with that order in which you have to see these. Isabel?
Can you explain like the second part? The x plus 1 minus x plus 1.
That's the quotient rule.
Oh.
That's Emma just applying the quotient rule to do the derivative of the inside. Because the derivative of x was 1, and the derivative of x plus 1 was also 1. So I'd add like x plus 1 times the derivative of x, well, that's just x plus 1. And then x times the derivative of x plus 1, well, that's just x times 1. So there's your numerator.
So you do like the 5 times, if you find the derivative.
So to do this part, that's the 5 quotient x to the 4th. And then to do the derivative of the inside, that's the quotient rule. Because again, if we look, the outside function is, we said was x to the fifth, right? Okay. Can we move to the next three? What do you guys think? Okay. Well, I guess it's just going to be 2 for right now because of where things land. So let's say Beck and Jacob's absent. Isabel. So Beck, you can get 4, and Isabel, why don't you do 5? This is our eraser. So just, that's okay. Nobody's expecting anything out of you right now. Nobody's necessarily even started studying yet. Can you erase the 2 circles that are up there too for people? That's okay. You're gonna have to apologize for it. You know. And again, you guys take 2 or 3 minutes, not all the time in the world. Doesn't have to be correct. We'll look at what you did. We can talk through whatever. You guys can ask me questions about stuff.
Am I 4 or 5?
You are 5. As they're working, feel free to kind of work on the same problem on your end, and we can kind of go through it together and stuff. Braden? So if you look at the test 3 on the OneNote, it has everything set up there. So I have part 1's no calculator. I have 8 regular problems and 1 multiple choice free response or multiple part free response problem. And then part 2 is the calculator section. It has 10 multiple choice and 1 multiple part free response problem.
Isn't the derivative of anything like e is just the same?
The derivative of e to the x is e to the x. That's what you're asking.
Yeah.
Yes.
How do you
Well, you can't really do anything with this in your calculator because it's not for a number. So when I choose the questions from the AP's question bank, there's a filter for calculator active and calculator inactive questions. But so many of these are just written by like a knuckleheaded math teacher like me. And I think half the time the labeling for the calculator non-calculator doesn't make any bit of sense to me. Like there's no reason you'd use a calculator to do this problem. It doesn't help you at all. So typically I ignore this unless I'm doing like a progress check through the AP site that they've created, in which case I would buy that their labeling of calculator versus non-calculator is, you know, that this is a problem we'd expect you to be able to do with a calculator. But those are often few and far between because oftentimes the calculator section, the non-calculator section, have a lot of problems that would be interchangeable that you wouldn't use a calculator either way. Mm-hmm. Yeah.
If x in this case is like tan squared x, do I have to find the derivative of tan squared x?
Mm-hmm.
And then would I put that in front?
Doesn't matter where, if we put it multiplied to the front or the back, it's multiplication, so you can do that in any order you like. Right? A times B is the same as B times A. What you're trying to end up at. Look at the G double prime up there in the question. So you need it written as something times e to the f of x. Can you take your answer?
I'm going to do h of x
Oh.
times e to the f of x equals all this.
Uh,
And then cancel out this.
where do you have? Sure, you could do that. And by G prime, do you mean G double prime?
Yeah, sorry.
It's okay. And probably the line above it too, right? Okay. But yeah, you could do that, sure.
Is 5B?
You're whispering and I'm deaf. Yes. Yeah. Yeah. If you weren't actually here. Sure. Which section do you want to do first? Tessa? Okay. 3-7. Okay. Let's say you can do 10. Oops, that's not the right section.
What's the derivative of secant squared? Just tan.
It's a chain rule.
I'm blind, I'm sorry.
It's okay. So looking at 4, this was a good one. I liked this one when I saw it. I like it because it was so abstract.
So should we look for this on our test?
So what Beck did, I think, was good. So Beck said, okay, I have my g of x here. So I'm just going to do the chain rule to get g prime. So that's the derivative of the outside, which is just e to the f of x, times the derivative of the inside, which would be f prime of x. We don't know what f of x is, so the derivative is just f prime. Is okay? Then he said, okay, well, to get the second derivative, I'm just going to do the derivative of the first derivative. So e to the f of x times f prime of x requires a product rule, because I have two functions that are being multiplied. So the first piece is e to the f of x times the derivative of f prime of x. Well, the derivative of f prime of x is f double prime of x. That's his first piece. And then plus f prime of x times the derivative of e to the fx, which is exactly what we did in the first derivative, so we know what that is already. That's e to the fx times f prime of x. So our last piece has f prime of x times e to the fx times f prime of x, which is what he wrote right over here. And since these are just three things multiplied together, we can multiply them in any order. So f prime of x times f prime of x is f prime of x squared, which is what he wrote right down there. And then he said, okay, well, this is what I'm trying to figure out, h of x. I know g double prime is the same as h of x times e to the fx. So he replaced his g prime with an h of x times e to the fx, and then divided both sides by e to the fx. And has h prime equals f double prime plus f prime squared, which is the correct answer. That's exactly what you should do. Mm-hmm. Pierce.
Wait, so on that second step, I can really say plus f prime x times the f x times f of x.
F prime of x.
Where do you get that?
When he differentiated e to the fx, right? So that's a product rule, and then the derivative of that piece required a change. Yep. It's because look at the directions. What's g double prime equal? So we just replaced g double prime with what it equals from the
and then
problem.
you divide over
And he divided both sides by e to the fx. Yep. Elena. Yes, correct. Isabel.
You can write it out of one note. I can't really see what this is.
Well, it's also like if you looked at my key, I did kind of the same thing, right? So again, like I tried to give you stuff that I would have used to do the problem when I wrote out the key. So it's just not just the answer. It's a little bit of explanation also, but this is the same thing, right? So there's the first derivative, there's the second derivative, and then there's me like factoring the e to the fx off. So this is like, there's my h, and there's my e to the fx. But again, if you want to write down what Beck wrote, you're welcome to do that too, right? So here, for the one that Isabel was working on, this one we should recognize as another chain rule problem, right? So like my f of x is like e to the x, and my g of x would be like tan squared x, right? So if I did, I guess I should have done g and h, huh? So if I do f prime of x, the derivative of g is just e to the x. So there's my g prime of h of x. And then times I have to do the derivative of tan squared x. Well, that requires a chain rule. So there's another chain. This is like two linked chain rules. What is the outer function for tan squared x? Good. J, H, I, oops, I should have done J here, huh? And the inner function is tan x, right? So when I do the derivative of tan squared, I'm going to get 2 tan x, and then times the derivative of tan x, and that is secant squared x. And then that's probably as good as we need to do. If I go look at this, yeah, so tans and secants are in my answer. It should be D here, right? Mm-hmm. There's all this is just chains. There's no product rule that happened in this problem. I use the power property to do some of the chains. So, Lena, that's kind of what happened there, right? If you wanted to get, like, real notation-y. You want to do a second one, Natessa? You want to do a second one?
Sure.
Okay, can you do number 1 from 310? which I think will be a good one given what you just had to do for the multiple choice. You guys ready for two more? Or a couple more anyways? All right, Rita, Pierce,
I'm sorry, can you quickly go run to the office?
yes, and Brandon, or I'm sorry, Braden.
I'll be real, I have no idea.
Yeah, erase that stuff.
I don't even know where to start on the 7. Alright.
And Rita, you have 6, right?
Yeah.
You have the hardest one of these 3 anyways.
Yeah, how do I start this one? Try to shoot.
I would just think about it as a chain rule, right? Where f is the outer function and a natural log is the inner.
Oh, so just. Okay.
So again, you guys, we're working on 6, 7, and 8 while these guys are working on their end. Feel free to kind of do your own work on your end as they kind of finish up here in another minute or two. We'll talk through these. What's up, Elena? Which one?
8.
Okay.
And I was doing shading.
You should.
But when I'm looking at it, I'm trying to yeah.
Why don't you just write as x to negative 1?
Oh, I didn't even think about that.
That'll make life massively easier, which would be my first suggestion for both Braden and Pierce with their problems.
Okay.
Well, I did general culture. Like the same question.
Oh my god, I got so much stuff.
Good job, Rita.
Is that right?
I think so.
Wait, I'm big as I thought. I think it just.
Looks scarier than it was.
Yeah, it's good. Oh, yeah. When I just thought about it, so
But
because it's the derivative of LSX.
and the AP likes questions like this because it is an easy calculus question, but you really have to understand the notation, right? Like what?
Yeah, it's
Huh?
what is it asking?
Couldn't they have just written it as x squared natural log x plus 2 natural log
I
x,
don't know. I mean,
and then asked to do the derivative of that? That's all. Yes, they could have, but what they wanted to do was like make sure that you could catch that this is like screaming chain rule in a situation where like maybe it wasn't completely obvious at first glance that it's a chain rule problem. And then just adds like a layer of abstraction, which I think they like.
yeah, they do. AP does like.
So what Rita did here for hers is we looked at the derivative of f of the natural log of x. That's a composition. That's a chain rule, textbook chain rule problem. So she did derivative of f, which is 2x plus 2, and then plug the natural log back into it. And then the derivative of the inside is the derivative of ln of x, which is 1 over x. So we had 2 ln of x plus 2 times 1 over x. Really, she kind of means like a parenthesis around that whole thing, and just write it all over x. So I answer A, that's correct. That looked good. Again, easy to do, looking at it and figuring out what to do, probably the trickier piece. So on number 7, Pierce is working on this. Come on in. Emma, you have 2 sets of sheets. Okay. So you have, I think this is the right thing at the end, but like, looked like you took a quotient rule. Emma, I got 2 for you.
Thanks.
Looked like you did the quotient rule to get there. I just think about that as 2x to the negative 1. I can avoid having to do the quotient rule altogether. So I just have derivative of the outside times derivative of the inside. And now I have to rewrite this to figure out what's going on here, but that's not too difficult because this is just like, so this is the only one that has the fraction in it that I'm looking for, so that's the obvious choice. But that's a super helpful. And Braden, I would have done the same thing here, right? Because it's almost the exact same problem. So, right? And then it's pretty straightforward from there. Figure out which one you need. It's the only one that's got the negative and the fraction. But feel good? Okay. Ready for some more? Oh, I guess we just have one person I can fit on here for this one. Carmen, this one's for you. Number 9, yes. Grab my eraser. Yep. Anything you need. So it can all be erased. You can just drop it on the floor, whatever, it doesn't matter. Thanks, dude. Oh my goodness. Good. That's correct. The only thing I would say here, Carm, is that really what you mean is like the sine x is here, like inside of the x squared, right?
Okay.
But I just lost my projector. There it goes back. But otherwise, that looks good. Anybody with questions on that one? No. Should be, again, like a pretty standard chain rule level. Oh, here's some good ones. All right, let's see. What do we have next? Jacob and Elena for 10 and 11. some stuff for us. So, use the eraser right there. Save your hand the mess. Okay. No, where's the multiplication going on? I mean, between the 4 and the x, I guess, but like you need a product rule to differentiate that part. So here, so it says h of g of x is equal to x, right? Why don't you do the derivative of both sides of that equation and see if you can get an equation for g prime. Huh? So we have h of g of x equals x, right? We're going to do the derivative of both sides of that equation. Your outer function is x cubed. Cosine of 4x.
Oh, okay.
So h, you have h of g of x is equal to x, right? Written down as the problem. So doing the derivative of the right-hand side should be easy, right? What's the derivative of x? Okay, so you know that side. So why don't you just write equals 1 when you need to work on the left-hand side. How do you do the derivative of the composition? Yeah, you have h of g of x. You have one function inside of another. Yes. So what's the chain rule for that going to say? It's It's more abstract than that because we don't know what the functions are for h and g, right? But symbolically, just like with h's and g's and like h primes and g primes or whatever, what is the derivative of h of g of x? Mm-hmm. So, in words, what does the chain do to do it on the side? So that's the h, right? Times the derivative of the right? So if I divide this over, I have an equation for g prime, right?
G of x, that is
Well, just move it over first. No, other one. You want to get g of x by itself because you're asked to find g prime of 7. Right? Now that's true whenever you have two functions that are inverses, which is what h of g of x equals x means. So now if you want to do g prime of 7, you're just plugging 7 in for the x's, and then you go to the table. It's g prime of 7, right? Not 7. Right? There you go. And now you're filling in 7 into your equation, so you have 1 over h prime of g of 7. And now you go to your table and look up g of 7. But they're inverses, right?
Yeah. Oh.
So if I know that
Actually, no.
h of 7 is equal, or I'm sorry, h of 3 is equal to 7, right? 7. G is its inverse. So I would say that in turn G is 7. So G of 7 is 3, right? That's what we just showed. So now you have 1 over H prime of 3. And now you can go to your table, right? So you have, the answer is 1 over 5. Sure thing. Yep. So 10's pretty tricky, right? This is like maybe one of the trickiest versions of one of these inverse problems. So it says selected values of the increasing function h and its derivative h prime are shown in the table above. If g is a differentiable function such that h of g of x is equal to x for all x, what is the value of g prime of 7? So when I see this, what's another way I can say h of g of x is equal to x? What else does that mean if this is true? This is an Algebra 2 topic that we expect you to remember. What else does this mean? It means that G and H are inverses. This is the algebraic definition for inverse. Okay? So should you remember that? Yes, that'd be a good thing to remember. So if not, you can always just do the derivative of both sides, which is what I told Jacob to do, because when I asked him what that meant, he couldn't remember either. So if I do the derivative of the left-hand side of this, that's a chain rule, right? So it just becomes h prime of g of x times g prime of x equals 1. We did the derivative of x, and we did the derivative of both sides of that equation, right? Derivative, chain rule. H prime of g of x times g prime of x. Derivative. X is 1. Derivative of x is 1. And then we want to know about g prime, so we'll divide this part over to the other side. Gives me this formula. This is true every time you have two functions that are inverses. This could be something you could consider a formula or a derivative rule for inverses. So that could be something, if you wanted to memorize it, you could memorize it, or you could just take this and derive it every time. It's either one, and I don't think it's 6 of one, half dozen of the other. And then we wanted then to do g prime of 7. That's what the question asks for. So we plug 7 in for x's. So we go to our table. Okay, what's g of 7? Fiddlesticks. I don't have any information about the g's. But I know that h and g are inverses. So if h of 3 is 7, that means h is sending 3 to 7. Its inverse, then g has to be sending 7 back to 3. So I know then that g of 7 is 3. This is what makes this the trickiest version of this problem, because they didn't give you how to find g. You had to remember this property of inverses. Once we know that g of 7 is 3, then we have h prime of 3. Now we can go to our table. H prime of 3 is 5, so I have 1/5 as my answer. Well, like, it just, if h sends 3 to 7, if I do an inverse, then it has to undo whatever the other one is doing. h of 3 is equal to 7. I wanted the 7 over here.
But why are you trying to find h?
I don't care about h of 3. I cared about that it was equal to 7. Because I needed a y coordinate of 7 for my h, so I can figure out what the g.
Because they're inverses.
So, wait, but if g of 7, that's not h of 7.
Correct. It's not h of 7.
So that,
H of 7 is 22, but that doesn't help me.
We're trying to figure out the G of 7.
Yeah.
We're given H of 3. It's like,
So if I know that h contains the 0.37, right?
yeah.
G needs to contain the 0.7, right? Because how do we find inverses? We swap the x and y's, right?
Yeah.
That's what I need. So that I know then G of 7 is 3. Not opposites.
Inverses.
In opposite means different.
Are inverses.
If you say opposite, it's wrong.
So if you know what H of 3 is, then 7 is find G of 7.
I'm so confused. Yeah, no, I'm not following this one.
We'll come back.
You'll get it.
We'll come back.
So I keep on getting 1 over 10.
So then Elena,
I did something really wrong, I think.
we'll see in a second. So we did, okay, our outer function is x cubed. Our inner function is cosine 4x. The derivative of the outside is 3x squared. The derivative of the inside is 4 sine 4x.
That's where I think I messed up.
Is it negative?
How do I?
Yeah, negative 4 sine x, or sine 4x, excuse me.
Okay.
So we have 3 times the inside squared times negative 4 sine 4x.
Is that always? Yeah.
Because what we did here was the outer function is cosine, right?
But like, why did
The derivative of cosine is sine, or negative sine, and we have then times the derivative of the inside,
Yeah.
and that's where the 4 is coming from.
So, where's he the? So yeah.
So this is,
Yeah.
that's okay.
We need to find
You just have, you lost your 4 on your x.
That's why I, okay. So I knew it had to be there, like I knew something was missing, and I knew it had to be solved, I just didn't know where it was supposed to come from. So just, I took the derivative wrong of like that.
No. Well, yes, because it should be sine 4x,
So
not,
I dropped my 4, okay.
you just dropped the 4, it looked like to me.
Yeah.
Which again, I think, given the choices, you would have figured out, like, I just have x instead of 4x, but everything else is, okay, this one's it, it probably just dropped the 4, you know, like,
That's what I was
you would have figured it out, I think.
between that or C, and I was like, I feel like there's a 4 in here somewhere.
Yeah,
So, okay.
yeah.
Number 12 is calculated.
Okay.
Yeah.
Braden,
It is,
she's, this is just bad notation on her part. She just says the outer function is x cubed, and the derivative of the outer is 3x squared.
Oh, yeah. Sorry.
Is really what she meant. She just like kind of was just jotting things down like she's doing a multiple choice problem that no one's going to care what her work is, just worried about her final answer. I think is what happened there.
Yeah, I would. I learned how to notate finally.
Yeah.
It took me a little while, but I got it now.
It's important in this course in particular because there's so much like layers of work.
And it's helpful.
Organization helps a lot.
Now when I'm looking back at it, it's really nice to know what I did.
Emma, what's up?
Because 11, I just want to make sure 11 is the G.
Yeah, that's 2 chains actually.
What?
2 chains.
Yeah.
But yes.
Okay.
The outer function is x cubed, and then the next outer function would be cosine. The inner of the inners is 4x. Yeah, should we talk about a test date though first
Yeah.
Yeah.
before class gets away from us here?
We definitely need to get to 16. I'm not just I'm not passing over
I
the
do. I should
That's
Friday
over
All right. So last time I had offered the option of pushing the test to Tuesday of next week. Show of hands for Friday.
Wow, that's
Okay.
pushed back.
Show of hands for Tuesday. Okay. Tuesday we'll do it. That's fine.
Thank you, Mr. Cooler.
So on Friday, I'm going to do a little bit of 3-9, and then we can do some more review questions. As always, if you're looking over these things and you have questions, you can come see me. Community time, you can see me. Not Friday, because there's no community time on Friday, but community time tomorrow would be fine. I have second period is my prep, or I'm sorry, first period is my prep. So if you have first period off, you can come see me. 7th hour, I have a study hall. If you are free 7th hour, you can come see me. Okay? So if you need me, find some time, come find me, get your questions answered. Yes, sir.
Do you know if we go to 3rd hour or first lunch?
Third hour.
If you have lunch 1,
Yeah.
you go to lunch right now. If you have lunch 2, you go to class right now.
Have a good one, Mr. Cooler.
You too. Right? Because it's 11:35, yeah.